guys, just got me another delivery from TruTech Tools here. I actually wanted to order another probe for my Testo 320. It was an ambient temperature probe, just like Eddie has for his 330. It actually works in the 320 also, and I got it today yesterday from TruTech Tools, and it's got the the actual fitting that goes on to the right here on the bottom of it, right here in this section right here. And what I'll be able to do there is actually, I can get on my gamma chart there, and let's say like on trains, I believe it's 35 to 65 degrees temperature rise. And with this, it'll actually give me the exact delta, no math, no nothing, just wham bam, you're ready to rock. And okay, and also what I got from Testo, I also got myself a personal carbon monoxide detector here, and this is the Testo 317-3. Pretty nice piece of equipment here. Comes with a nice case here that I can actually hook on my belt loop, and it's pretty lightweight. It's got the sensor back here, and it's got an audible alarm, so this thing will go off and alarm you and let you know what's actually going on at the time. Your parts per million here on your CO. You can actually set it to a CO that you want to set it with. Let's see, and it gives you like a little list here of 30 ppms maximum workplace concentration during an 8-hour working day, 200 parts per million, light headaches within 2 to 3 hours, 400 ppm ache in forehead area within 1 to 2 hours, spreading to the whole head area, 800 ppms dizziness, nausea, and limb twitching within 45 minutes, unconscious within 2 hours, 1600 ppm headache, dizziness, nausea, 45 minutes, dead within 2 hours. Ooh, that's not good. 3200 ppm headache, dizziness, nausea, and within 5 to 10 minutes, dead within 30. 6400 ppm headache, dizziness, nausea, within 1 to 2 minutes, dead within 10 to 15 minutes. 12,800 ppm, dead within 1 to 3 minutes. So, did I really need this? No, probably not. I could have probably carried in my Testo 320. However, I'm not saying it's super bulky or anything, but this here, dude, all I really got to do is just click this puppy on and let her clear out in ambient. And here we go. So now whenever I walk into anybody's home, I can safely walk into their home. So just another tool to the arsenal here, guys. But anyway, been getting some comments about I was testing outside and all that. So actually what I'm going to do today, I'm actually going to run a combustion analysis out here today. I've got my 90% furnace fired up here, and we're going to run some analysis out here and a draft out here, and we're actually going to go into the house and do it again and see what type of different measurements we get. Okay, guys. Okay, guys, we're going to go ahead and hook up our Testo 320. And you can see it. I don't know if y'all can see it, but there's an arrow right here, and there's an arrow right here on this piece. So that basically all you do is you line up the arrows. Well, there we go. And just turn the bayonet style fitting, and you're ready to go. Alright, so what we're going to do is we're going to turn on our instrument. Testo 320 V1.01. And let her fire up here. Okay, we got 16 seconds for the flue gas analysis. 13, 12, 10, 9, 8. Now my furnace has been running a good 10 minutes here, so let's go ahead and start our flue gas analysis. Natural gas. And right now it's telling us our ambient temperature here. It's a little cooler than that out here. But anyway, let's go ahead and get this puppy started. What we'll do is we'll take it and we'll hook it up here to my fence post. And let's go ahead and set her on in there, guys. Haven't put a new filter in it yet, and I haven't had any border yet. So maybe I'll put a new filter in it today. It's kind of fogging up my my camera here. Let me back up a second. Okay, we're looking at 110 degrees stack, 8.2% on our oxygen, 1 part per million CO, 2 parts per million CO. We just put it in there, so let's let it run for a second, guys. All right, I'm gonna let it run for a minute, and we'll get right back to it. Okay, guys, we've had the Testo hooked up to the American standard for a good 15 or 20 minutes now. I'm just shooting these videos to actually learn how to use my instrument correctly. Jim Bergman's actually going to do a really great video on the 320 here. He's going to put it into probably 4 to 5, maybe even 6 different parts on it. He's going to go over everything thoroughly. This is just for me. Okay, now we've had it running for a good 20 minutes. Our stack temperature is at 113.2, fluctuating in between there to 0.5. Our O2, our oxygen, is at 8.3%. Recommended is 5% to 7%, so we're up just a little bit. Our CO, our carbon monoxide, anything below 100 parts per million undiluted, it states that it's okay. So we're looking in fine shape here. Our draft, we're not testing that yet. Like I said, we're doing this outside. We're going to go inside with it. This is a 90% furnace, and on typical readings, draft-induced sealed combustion gas-fired burner, 90% furnaces, the efficiency rating should be anywhere from 88 to 92%, and we're at 92.2. Excess air is 58.5. I believe the optimum excess air is going to be 50%. Our carbon dioxide is at 7.06, and carbon dioxide should be anywhere from 7% to 8.5%. So let me go ahead and save this to my clipboard here by hitting this button right here, and it should say save data. Data is stored for printing. Okay, now what we're going to do is we're going to pull the instrument. Look how much they condensate, guys. All right, so we've got the instrument pulled, and now we're going to hit stop, and we're going to escape, and now we're going to go for a draft measurement. So let's go ahead and hit OK. I don't know if you can see any of that. Sorry about that, guys. Go ahead and hit OK for the draft measurement, and go ahead and hit the green button again till it let her zero out. We'll go ahead and get her out of the direct line of the exhaust here. And we're down to 5, 4, 3, 2, 1. Okay. All right, guys, let's put her back into our stack. Stay there. And we'll let her run for a minute. And let's see. And this is probably not a true draft reading. However, we're doing this for giggles, guys. It says out here it should be 0.10 to 0.24. This is, I guarantee this is not the true draft reading, but like I said, we're just going to do this just for testing purposes, and then we're going to go back downstairs and we're going to actually perform a draft on the furnace itself at the furnace. And I'm going to try to be at least 18 inches away from my inducer motor, so we'll do a little measurement down there too. But right now it looks like we're hanging at 111 now on our stack, 112, 111, 112. And we've got a 0.080 inches of water column in our draft here, which is significantly below where we need to be. Well, not really significantly, it's just a few tenths. But like I said, anyway, this isn't a true draft test. So we'll let it run for a minute or two, and then we'll take it on downstairs. And I want to use my new temperature probe so I can actually do a printout with my Delta. Well, it came with a nice little magnet too, guys. I have to show you that too. Okay guys, that's it for now on the outside testing. We're going in the house. Let's go ahead and get our flue gas analysis we did outside here. Go ahead and hit the print button. There we go. I didn't think I stored my Okay, let's go in the house and try it out. Get my 90 back on here. 45. Good to go. All right, guys, just for giggles here, we broke out the Testo 317-3 carbon monoxide detector. Supposed to be one of the finest detectors on the market today. Pretty much pleased with it. The only thing I really don't like about it is I figured for the money they would actually give me a backlight in here, especially in locations that we go into. But anyway, other than that, I think it's a fine instrument, don't get me wrong. But what I'm going to do now is I'm going to actually take it in the house and do a simulation like if we were to have a CO problem. You know, I smoke cigarettes, or if y'all don't know, I do, and it's a nasty habit, and I want to try to quit, but anyway, I advise anybody that does smoke to quit, but that's their own prerogative. So, all right, we're looking at 1 ppm now, and I've got a cigarette fired up here, and let's see what we shoot up to. We get a good draw off this thing. So it looks like it's got a stronger beat the higher it goes. Let's see when it quits ticking. I'd say probably around 5. It's still giving us an indication of CO. 4 or 12, 11, 10. Now, the way the instructions were, I can set up an audible for whatever I want to do. I might talk with Eddie about that. I'd like to get it to start clicking around, I don't know, maybe 5. I'm not sure what he sets his up to. But anyway, let's get back to our testing. Guys, we're back down to the Testo 320, back down here to the basement. And what we're doing is doing a little comparison of testing outside as opposed to testing inside. What I'm going to actually do here is I'm going to start it up. I'll make sure I have my probe out in the air here. And we're watching her count down 14, 13, 12. So we're going to let her zero out. And as you can tell, it's later on in the evening. It got pretty hot in the house earlier. Okay. Now, one of the significant tests we can do down here at the furnace here is we can actually test the heat exchanger actually for tightness to see if we got a potential leak. And basically what that's going to entitle is let's go ahead and hit our button here, OK. Go ahead and get our pump started. We got natural gas, and let's go ahead and start our pump. I'm going to go ahead and put the probe here into the cone in the airflow there. I'm going to go ahead and bottom it out, bring it back up a hair, and go ahead and tighten it down. Might have to move that around just a little bit. And actually the test that we can actually perform here is very significant. And it's actually done right here off of this where it says 21.02, which is oxygen. And what it's going to do is actually, this is a sealed chamber here, and what this is going to do is actually, if this thing rises, it's going to tell us we have a potential leak. It may be a heat exchanger, maybe something else. So what this thing's going to do is, once we fire it up, the gas valve opens, we have flame ignited, and we're starting to heat up the heat exchanger. You're going to see this start falling. And it could possibly fall down to 9 or 10. Let's just say it falls to 10. As soon as that thing hits 10, whenever that blower kicks, as soon as that, like say it hits 10, the blower kicks on. Well, we don't want to see it rising up to 10.1, 10.2, 10.3, yada yada yada, on and on and on. That's it's showing we have a leak somewhere. So, and actually too, I got the reading on this, and I went ahead and copied. I made several copies of these, and I'm actually going to take whatever my tests are and my printouts. I'm actually going to attach it to one of these highlighted where my customers can actually see that we're actually in range. That's another thing. I've been messing with this off and on all day, and something has happened to my folder where it's not printing my stuff correctly. And I don't know if I'm doing something wrong. I didn't really tamper around with any buttons or anything. But you know how when I first started doing this, my Fritz Rochester would come up, Rochester's Heating and Air, yada yada yada, my telephone number and all that good stuff. That's not really coming up, and if it does, it comes up in the middle. But let's go ahead and get started here. Like what I was saying down here is, I read a little further, and it says measurements must be made in the PVC flue pipe, and temperature of the combustion air must be properly referenced in the intake pipe with an auxiliary temperature probe or other process to get combustion efficiency results. Sorry about that, I can't see without my glasses. So what I did is actually that little differential temperature probe I bought from TruTech. I've got it sitting in my intake here, my combustion intake. And what I actually did too is I got to reading, I pulled out my manual, and this combustion intake, if it's a one pipe system and you're drawing combustion from the basement or wherever you're drawing from, this has to be a 12 inches or taller. Okay. Now I do have plenty of combustion air down here, so you can take that up with my inspector there if you don't think so. But anyway, what we're going to do is we've got it jumped out at the furnace. And like I said, we want to watch this O2 rating. So let's go ahead and fire her off. Here we go. Now we're going to watch this. There's the inducer. As soon as it fires gas, we're going to watch this thing start dropping. Let's hear it. Wait for our gas valve. You should hear that click click. Come on, girl. There it is. All right, now we've established flame. Okay, now we're going to watch this 20.9 take off. And we'll watch our parts per million here, our CO, just jump all over the place until we get it settled down. My furnace burns pretty daggone hot. It's recommended 120 degrees or less. My furnace is burning probably at 128 to 130, but it's because of my funky duct on here. And you'll be able to hear that in just 1 second. You can see her drop down to 10. Listen for my duct to hit. We're at 10.4, or my blower to kick. 10.1, 9.9, 9.7, and we don't want it to rise, whatever my blower kicks on. 9.5, 9.3, 9.2, 9.1. It kicked at 9.1, guys. 9.1 or 9.0, whatever you want to call it. I'm going to call it 9. We'll call it 9.1. All right, we don't want to see it rise over 9.1. That would indicate a potential leak. Now, it might not be the heat exchanger. It possibly could be, but it could be other things. You know, that's when you want to start checking things out thoroughly. But anyway, let's let her heat up real good. We'll reference back to what we did today. Outside we tested, and we got a 113.5 stack reading outside, 8.3% oxygen, 3 parts per million carbon monoxide, 5 parts per million carbon monoxide air free, We didn't do a draft test on it. We had 92.3 efficiency rating, and we had 58.5% excess air, and I believe optimal is like 50, and we had 7.06 carbon dioxide, CO2, and our ambient was 65.5. Okay, so now we're rising here. We're at 108.9. Our CO parts per million are dropping. I foresee that getting down to probably around 2 or 3 or so. Right now we're showing 93.6 on our efficiency rating. That's going to probably drop a little too. 6.9 on our carbon dioxide and 60.8 on our air. Get this thing in a hot spot here. I know this thing runs about 128 to 130, so let me adjust this a little bit. This test was it was pretty cool. I've did it a couple times today, and the reason I actually did it a couple times, I don't know what's going on with my folders and my printer. It's just not working correctly. Maybe I can get a clue on that. Maybe Jim will clue me in on it. But you know, like I said, usually where it says Fritz Rochester, Rochester's Heating and Air, you know, telephone number, yada yada yada, it's not coming out. And when I did do my combustion analysis, I saved it. I hit stop, saved it to clipboard. Data had been saved, and I went and then I went ahead and I did my draft. Did the same thing, push stop, saved it to clipboard, and then I did my differential temperature. Did the same thing, hit stop, hit the clipboard. Data had been saved. Went to print out, and it only gave me like my combustion test, and it wasn't the full amount of my combustion test. So I'm hoping somebody can clue me in on this, guys. It's one of the main reasons I bought this tool was so I can just take it right out of my case and do this test we're doing right now for my customers. And like I said, the main thing I wanted to do is be able to show them how their stuff is operating. I don't want them to have to come down in the basement and look at this or draw it out longhand. So I'm sure it's probably something that I've done, and maybe we can correct it here. So anyway, let's give her a few more minutes. We stopped the camera at 10:08, and we're now at 10:18, so approximately 10 minutes on 11/11/12 here. We're running at stacks running at 127.6. Like I said, I've seen her in between 128 and 130. It looks like she's still rising a little bit. Our oxygen's leveled off. We're at 8.2%, looking good. 2 parts per million on our carbon monoxide, CO, and 3 parts per million on our CO air free. Our efficiency on our furnace here is 89.1%, and our excess air is 57.3, and our CO2, our carbon dioxide, is 7.12. Everything is pretty much within range. Our oxygen's a little high, and of course our stack's a little high, but that's just because of my ductwork, guys. The machine here, the 320, seems to be working great. However, I have to be able to figure out what's going on with these folders, man. I haven't been able to figure it out, and I've read through the book. I don't know if it's just over my head or what, but I need a little help. I actually was getting a error code earlier that was flashing in here, right here where it says T320. It was giving me T320. It was giving me some sort of little looked like a yield sign or something in there. And I hit the error. I went through my stuff here, my options, and I went to my device, and I hit the error code, and it gave me some kind of funky code, 03777 or something crazy. But anyway, I turned the machine off and turned it back on, and I guess it must have reset itself or something, because it went away. It kept flashing right here though throughout all the tests I was conducting. All right, we're at 128.1. 128.1, 127.9, 128.1, 8.3. Our oxygen hasn't moved a bit. CO hasn't moved. Efficiency's dropped just a hair. excess air is about the same, and our carbon dioxide really hasn't moved either. So 128.3, 128.5, 128.3. If it keeps fluctuating in between there, I'm gonna hit the stop button here and then the clipboard. Okay, so 128.7, she's still rising. 128.3, 128.7, 128.5, 128.1. Okay, she's dropping, coming back up, dropping, coming back up, dropping. Okay, so I'm going to go ahead and hit stop. At 128.5 we stopped, and right here it says ready, guys. So what I'm going to do is I'm going to hit the clipboard. Data is stored for printing. Okay, now what we're going to do, we've already stored this data, okay? And now we have like this little icon up top here, and it looks like a little folder. So like I said, I need a little bit of help with these folders. We saved our flue gas analysis and we put it in our clipboard. Now we've got our, we're setting it to draft. We've got our testing probe outside of the flue, and we're going to go ahead and zero it out. Go ahead and hit our OK button, and go ahead and hit it again, and it should start zeroing. Now I just read in the book also, this test shouldn't be done no longer than 5 minutes. So what we're going to do is, we've actually had this thing running for a while. It's 10:29 now, and I still got her jumped out. So by 10:35 we're going to pull this puppy, no matter where it's sitting. All right, guys, we're zeroed out, and we're ready to rock. So let's go ahead and get our probe in there. Bottom it out, bring it back a taste. Okay, guys, we're at 10:29, and okay, we're at 126 now. We're at 0.25, 126.7, 126.5, 126.7. We're at 0.25. She's rising. 126.9. We're going to let it run for a good 3 or 4 minutes, and then we're pulling it. 127.2, 127.6. Okay, guys, I'll fire the camera right back up here in just a couple minutes. Okay, guys, it's 10:33, so we've had this thing running a good 4 minutes. We're at 128.7, 128.5, and we're at 0.25, 0.26 on our inches of water column here. So I'm going to go ahead and kick it. We're going to turn it. We're going to stop it. Okay, when we stopped it at 128.8, and we're at 0.25. And on here it says 0.10 inches of water column to 0.24. And of course our stack's high, like I said it was going to be. But our water column is pretty daggone close. I wonder if it's, I'm not sure if it's got something to do with using my temperature probe in there or not, but I'm not sure about that. But let's go ahead and save it to clipboard. Okay, data has been stored for printing. So now we have our flue gas analysis, our combustion analysis, and our draft analysis completed and saved to the clipboard. So both those tests should print out for me. Alright, so now what we're going to do is we're actually going to take our brand new probe here we got from TruTech Tools, and we're going to go ahead and we're going to take it down here, and I've got a hole already drilled from a while back, and we're going to go ahead and put our probe in here and stick it in there like so she sticks. She's in there good, and I reckon what we can do now is, we actually saved it to clipboard. We can go ahead and hit escape, and we're going to come on down here to focus. We're going to come on down here to differential temperature. I unboxed this thing 10/11 of October, and now it's 11/11 of November. So we've had this instrument for 1 solid month now. I know it takes time and everything to do things, but guys, I wish y'all to I really could use my my differential pressure tester. Not only for static pressure, but to test gas valves on this particular furnace. So not bitching, but whenever y'all get a chance, could holler at me, and I'll be glad to send this thing back into you so we can get this bottom changed out. What I heard was basically on this unit, it's the stuff's already inside here. All we need to do is have a quick change of the bottom here. So like I said, not complaining, just ready to rock. But okay guys, so let's go ahead and get our cone out here. And we'll set our probe down somewhere safe. We'll go ahead and grab our cone. Try not to inhale. All right, and we'll go ahead and place our cone up here, out of the we're a good ways away from the heat exchanger. And I love this, man. I love that new probe. On my particular furnace, this is an American standard furnace. A lot of Trane furnaces also. The temperature rise on them is 35 to 65. Now what you want to do for the optimum temperature rise, you need to be dead center of that. Now you need to look on your gamma chart in here, and it'll tell you where everything's at, and what your temperature rise is going to be, all kinds of stuff, what your gas valve is supposed to be, and yada yada yada. But anyway, on this particular furnace, it's 35 to 65. So half of that would be 50. And I mean, to come up with that real quick, you could say 15 plus 35 equals 50, and 50 plus 15 equals 65. So you know that's dead even. There's actually a little calculation you can do. But I know that from these furnaces. I know it's supposed to be 50. However, I'm pretty daggone sure we're going to be running a little bit higher than that. So let's go ahead and get started here. Let's hit the, come on. Let's hit the OK button down here. And what we have here is we have T1 is going to be our supply temperature. T2 is going to be our return temperature. And this is going to be our delta. This is going to be that number we want to see. We'd love to see 50, but I guarantee we are not going to see that. But let's go ahead and hit OK or go. And this thing's pretty quick. We're probably going to be burning about 136 here. Maybe 138, maybe even 140. But we're at 10:37 right now, so we're going to let this thing run for a couple minutes and we'll get right back to y'all. Okay guys, we're reading, it's 10:49 now. I'm sorry I had to take a telephone call. So she's been in the heat a pretty good time now, and she's running 136.8. We're at on the supply, we're at 81.7. It's good and freaking toasty in here now on the return, and we're at 54 on the delta, which is looking pretty daggone good. Like I said, we've got our brand new probe in down here at our return that we got from TruTech, differential temperature probe for the 320 or the 330, and we've got our perspective probe here hooked into our supply, which is a moderate distance from the heat exchanger. All right, so we're running 137.3. I'm going to go ahead and hit the stop button. See if she goes back down a little bit. 136, 137.3, 137.5. I think we're stabling out here, guys. 137.3. All right, so I'm going to hit the stop button here. We have stopped it. We're at 137.5. We're at 82 on our return, and we're at 55.5 on our delta. Now, like I said, the heat rise on this particular furnace is 35 to 65, and 50 would be optimum. I think 55 is okay for the ductwork that we have here. All right, guys, well, let's go ahead and hit clipboard. Now, I've done 3 tests now, and each one of them I hit the stop button, and then I hit clipboard, and that's what we're going to do right now. What are you doing, boy? Huh? You say it's hot? Okay, guys, we're going to hit the clipboard right now. Data has been stored. Okay, we're good to go. I think Sarge wants me to kill the furnace. I'm sure Mom does too. So we're going to shut her down. We're going to go ahead and escape. I know this probably doesn't mean a hill of beans here, but I've been actually going right back up to where, you know, I was testing at, which our first test was flue gas analysis. I know that probably doesn't have anything to do with anything. But the problem I've been having, I don't have a problem with the instrument other than I can't wait to get my pressure differential. But this thing, I don't know what's happening with it. Like I said, I actually got an error code earlier after we got done testing outside. As you can tell, it's almost 11 o'clock at night here, and we did our testing, I believe it was around 10:30 this morning on the outside. Well, actually it was 11 1101, and we actually got 113.3 on our temp stack, 8.3 on our oxygen, 3 parts per million on our CO, 5 parts per million on our CO air free, 92.3 efficiency gross, 58.5 on excess air, and 7.06 on our CO2, carbon dioxide, and 65.5 ambient. Okay, well, let's go ahead and now see. I should get a printout just like this. Actually, listen to that thing condensate, guys. But actually, I should get three different printouts. On one printout, I should have my flue gas analysis, followed by my draft, and followed by my temperature differential, my delta. I don't care what order it's in. I just want to have those printed out for me. So let's go ahead and fire this puppy up. Make sure we got our green light here, and we do, and we're lined up pretty good with it. So let's go ahead and hit our print icon and see what we get. Please wait. Come on, baby, print for me. Like I said, I don't even know what happened to the my Rochester's Heating and Air and my telephone number on it either. I'm kind of a little, I don't know, a little disgusted, I guess is what you'd call it. It's not going to print. I have brand new batteries in this thing too. I just put them in there this afternoon. Alright, let's try it again. Print. Print, baby, print. There we go. Alright, now we're starting out with Rochester's Heating and Air. Fritz Rochester. And that's it. We got to figure this out, guys. Okay, come on. Maybe it just wasn't in the line of fire, but heck, I'm not really that far apart from it. Okay, combustion type. See, it's not even saying natural gas on it. Okay, we're getting our 128.5 temp stack, 8.2 on our oxygen, 2 parts per million on our CO, 3 parts per million on our CO ambient, 80.1 on our ambient temperature. It gave us it's calling it draft, but this is actually our differential test here, and we had 137.5 on T1, which is our supply. We had 82.0 coming in on a return. Like I said, it's hotter than hell in here, and our temperature differential was 55. Now we also did a draft measurement test. I don't know where that's at. If I just have to keep hitting this or something, let's see. But I figured it would print everything out at once. Let's see if this gives us our draft measurement. Location site, combustion type, second combustion type. See, I don't understand that. Okay. Now it's giving us our temp stack 128, our oxygen 8.2. See, it's going through that again. Now it's giving our draft, which was actually our temperature rise. I don't understand. Let's actually go back to our draft measurement. I'm sure it's in there. Focus. Okay. And there's our draft measurement. It was 128.8 at 0.257. Heck, I don't know what to do. I mean, should I hit clipboard again? Data is stored for printing. Let's go ahead and print it. Giving us our site, second combustion type folder. It's not doing it, guys. It's giving my differential. It's giving me my differential temp. Let's see here. No, actually that's what it is. It's calling, that's what I don't understand. It's calling this my draft measurement differential temp. Okay? At 128.8. and 0.257 inches of water column, differential temp. And it's calling the other one, the actual draft, it's calling it the basically the differential temp. So maybe I can get a little advice from you know, one of the fellas out there or something, or Jim or somebody. I just want to get this down to a science. And like I said, I thought I'd only have to press this thing one time and it would give me all of my readings. So, but anyway, I guess that's it for tonight. I appreciate y'all watching, and I reckon we'll be seeing you real soon with the Testo 320 again. All right, guys. Bye.